Okay, this one reads, assume that both populations are normally distributed and test the claim whether or not mu1 is not equal to mu2 at the 0.01 level of significance for the given sample. And then part B, construct a 99% confidence interval. So I'm going to actually skip part A. This is just like the last one, and you need another one to be able to do sort of on your own. You're going to use StatCrunch for this, so go to statcrunch.com, and they've given you the summary statistics. Just put it in just like we did the last one, and you ought to be able to do this one. So I'm going to skip ahead to the confidence interval. Okay, now we're going to do the confidence interval, and so instead of selecting hypothesis testing, we'll go ahead and populate these values here, the sample mean, sample standard deviation, sample mean, and so on for sample 1 and sample 2, just based on this table here they give us. Select the confidence interval, and it says 99% confidence interval. This usually will correspond to the significance level. So if it's 0.01, we will do a 99%. Not always, but that's generally what we do. And press compute. So there is our interval. So our interval is from about, in this case, negative, let's see, it's around the 2 places, so negative 2.96 to 6.56. Okay, and so notice what we have in this interval. 0 is in the interval. So that's another confirmation that we would fail to reject HO. So again, we are 99% confident that the true mean difference between these two independent means is between negative 2.96 and 6.56. So since 0 is in there, again, that's another confirmation, as well as the p-value in this particular case. We had a pretty high p-value here, so we failed to reject HO on a couple different counts. Often what we do is when we don't run a confidence interval until we do reject HO. So some iterations of this problem, you might end up rejecting HO. You get a super small p-value. And when that occurs, your confidence interval would not contain 0. So I'm curious if that happens to any of you when you're doing this. And I want you to see that. We've done that in other contexts before, I think with a single mean and with dependent means, with matched pairs. So that can also happen with independent means, right? So I hope that helps.